All right, I'm drowning. All right, so we're looking at 89, and we're changing to volume. So if you would get your formula sheet out and flip it to the back, we see that we have the formula sheet for volume. You guys are something else today. All right, so we still have our basic formula for the area of a triangle, a circle, your rectangle or square, and your circumference of a circle. And there are reasons we need these basic formulas. Now, remember, there's a big difference between a pyramid and a prism, okay? So, prisms. Whenever you look at a prism, you have those two bases. Remember the top and the bottom? And so here is a pentagonal prism. You've got a pentagon on the top, a pentagon on the bottom, and then rectangular sides. Here's a hexagonal prism. Hexagon on top, bottom, rectangular sides. When you find the volume of anything, you are truly finding the area of the base and multiplying it by the height, thinking about how to fill it up. So on all of these formulas for a prism, it says B times H. The B stands for the area of the base. That's a big deal. So V equals, I'm going to put area of base times height of prism. So that's it. There's not actually going to be a lot of formulas for prisms. You find the area of the base. So if it's a triangle, find the area of a triangle, multiply it by the height of the figure. It's basically how much can we fill this up with. Rectangular prism, well, the volume is length times width times height. Isn't length times width the area of the base? Length and width, and then we multiply by the height. So that's what you're doing. Now, doing a pentagonal prism or a hexagonal prism, those will be harder because we don't have a formula that we know to find the area of the pentagon or the hexagon. So there are formulas out there, but we're not going to focus on those. Yep. This is the formula sheet. I'm going over the formula sheet. Now, pyramids, it's the same rule. You're going to find the area of the base and multiply it by the height, but you take a third of that. So if I would take a box and put a box over top of this, only a third of the box would be filled up with the pyramid. That's the rule there. So this is the area or the volume of a pyramid is 1/3, and the B stands for area of base. And then we multiply that by the height. Now, when I say the height, we're talking about the altitude, height of figure. So not the slant height. So let me bring that up again. When we were doing surface area, we needed to know the slant height because it was basically like looking at the area of the side. We didn't want how tall the shape was. We wanted how tall the triangle on the side was. When I talk about volume, I need that height, that right angle coming down. So if you have the slant height, you're going to have to find the height, what it would take top to bottom. And again, it's a third of the volume. So if you have a pyramid versus a prism, they have the same bottom, but here's a prism. And then you have a pyramid that's the same, but we turn it into a pyramid. The pyramid is going to be a third of the prism. So I don't need you to memorize these formulas, but you do need to be able to put them together. Now, a sphere does have its own formula, and it's 4/3 pi r to the third. Okay? Oh, you 100% have done this before. I mean, you guys did it in elementary school. You probably did it in pre-algebra. Well, you did. You did 1 + 1.
I think I did that. I did a hard time 8th grade, maybe.
Well, you probably did again because of Keystone testing or PSSAs. All right, so let's go here. The top of this is all about the objectives. We're talking about the volume of a box of cereal, but let's do this. The volume of a solid is the number of cubic units contained in the solid. So think about the number of cubes to completely fill the picture. So if we come down here, you have a rectangular prism, okay? You can see the width, the length, and the height. Now, the shortcut we know is volume equals length times width times height. So we could simply find that by 6 by 3 by 4. Guys, the 6 by 3 is the area of the base, and then stack it up, and that's what we multiply by 4. So what's it really look like? Can you picture little sugar cubes? Do you know what I'm talking about, the little sugar cubes?
No.
Really?
The one you put in
Yeah,
coffee?
yeah, those little like smashed up sugar
I don't think
cubes.
anyone uses sugar.
I don't think anyone uses them anymore, but that is the perfect thing to explain volume. The idea is, can you imagine laying out the sugar cubes to stack this whole bottom? If you have 3 here by 6 here, that's 18 sugar cubes, right? Then we can stack it 4 sets high. So you have 18 in the bottom times 4, and then that would be how full it is. So it does. Now, if you're thinking about this, square units, look at the floor. Those tiles are about 1 foot by 1 foot. So if we say this room's, 225 feet squared, that's literally 225 squares on the floor. So when we talk about cubic, inches cubed, you're talking about how many little cubes would fit in here. Okay, so if you have a cube, I wish I had something that was a cube on my desk, and I don't. But if you have a little cube, think about a die. It'd basically be, if you're doing centimeters, it'd be 1 centimeter tall, 1 centimeter across. Each one of those is 1 cubic centimeter. And so picture how many of those we would fill in there. Okay, so always area of a base times height. That's what we're looking at. So let's do this. So first we have the volume of a prism, and this is a rectangular prism. So the volume of any prism is base times height. And again, I'm going to clarify, that's area of base. Notice it's a capital B, where lowercase b is like the length of the base. Okay, so in a cube, the volume is length times width times height. That length times width, that's your base. Length, width, height. So that's pretty simple. We don't have to work too hard on that. So to find total volume, we need to count all the cubes in the prism. We can count them one by one, or we can use our multiplication. And they're telling you the shortcut is area of base times height. Okay, we define that up there, area of base. All right, so this is the volume of a prism. Let's do a couple of rectangular prisms, and it says nearest 10. All right, here you go. You got a lot of dimensions here. What do I need? Length times width times height. So guys, do you see that the 5 up here is the same as the length down here, and that the 8 is the same as the width? So I really just need these 3. Don't let the extra throw you off. Make sense? Did you all label LWH? All right, so volume equals length times width times height. Length is 5, width is 8, height is 4. And what do we get, friends? Type it in the calculator. And what would you label it? Yes, because we did feet times feet times feet. Perfect. So pretty simple. Actually, volume is a lot easier than the surface area of a prism, isn't it? I think so. All right. Which one do you want to use length, width, and height on number 2? What do you want 12 to be? 12 would be the length. The width, what would this be? What number would that be? 9. It's the same over there, okay? And this would be the height. So if I'm using these 3, I can ignore that, or I could use these 3. But don't be thrown off by the extra. Now, volume is length, width, height. So 12 by 9 by 10. I couldn't read my writing. What do we get, guys?
1080.
What is it?
1080.
1080. I agree with you. Volume is 1080 what? Yards cubed, because volume is cubed. We multiplied the units 3 times. Okay, now look. We don't have a prism. And maybe did you guys add that on your formula sheet underneath the prism? Length times width times height? Okay, saying that you have your formula sheets out.
Wait, what did we put on it?
Well, underneath your little cube, actually write length, width, height. Someone gave me a little bit of a hard time about what this is. I make a cursive L, or you can make a capital L, It's really proper to do an italic or a cursive L to show length so it doesn't look like a 1.
You just gotta show off.
Did I know my cursive? It is. It's my secret code. All right, guys, this is not a cube, so I have to do it differently. If we're talking about volume and it's area of base times height, what's the base of this figure? It's a triangle, right? So if it's a triangular base, isn't the area of the base half the base times height? So notice we're using the term base twice. Capital B stands for the whole base, which is a triangle. So the triangle would be half of the base of the triangle, which is 11, times the height of the triangle. The triangle is 6.2. Then you would take the area of the triangle times the height of the figure. What's the height of the figure? 9. That's your height. Did I need the 7 or the 10? No, and honestly, I couldn't use the 7 or the 10 because it doesn't help me with the triangle that I need. So times 9. So you have some extra information sometimes. Okay, what was this again? What was this, half of 11 times 6.2? Where did I get that? That was yep, the area of the base, which was in the form of a triangle. So I'm using my triangle formula here. All right, just type this whole thing in the calculator. Now, if you want to separate it, the area of the triangle is 34.1, and then the height is 9. So what's my overall volume? Yep, centimeters. Yippers. 306.9 centimeters cubed. Okay, now number 4 is a little problem for me because it's sort of flipped around. I think it's easier to see when it's sitting. So if this is something that bothers you, I guess you could redraw it, but you could also just sort of flip it to look at it. And I'm talking about that because this is, again, a triangular prism. So the base is a triangle. Sort of highlight that triangle for you to see it. Do you see the base? All right, I'm glad you see that with me. Now, what do you notice about this triangle? Look at that little, it's a right triangle, isn't it? No, it's not the sides are rectangles. Okay, but the triangle we colored, isn't it a right triangle? It is. See that little corner there? That's important because I need, for the volume, I need the area of the base times height. So the base is a triangle, which is 1/2 the base of the triangle times the height. Or you could use, maybe like this is the base and that's the height. It does not matter. 6 times 8. What's the height of the figure? Well, turn it sideways. 4. This is the height of the figure. The height of the figure is what does it take to connect the two parallel sides. So if you lay this on the triangular base.
But that's at the bottom of the triangle.
Well,
The height.
see how this is the bottom and this triangle's the top? Here's your base in green. See it? We can't see this side. It's underneath it. And then the top of the triangle. Yeah, if you're laying it down on this triangle.
Yeah, I see it.
Okay.
You look at it from on paper.
Well, I know, and it's hard because it can sort of turn. This is the top. Do you see the 4 connects them? Yeah. So even though it was this way, if these are your bases, what connects the bases is your height. Do you see it over here? What connects your bases, that's your height. So the rectangular side has your height. So in this problem, the 10 is extra, isn't it?
Yeah.
The only reason I would need that 10 is if I was missing one of the triangular sides. All right, so area of the base is a triangle times the height, which is 4. All right, throw that in your calculator. Area of the base is 24. So it's literally just find the area of a triangle, multiply it by the height of the figure. Does anybody agree with my 96? Why? And it's.
You haven't got anything wrong today, so you guys can tell me.
Oh, I'm sure I will. All right, I'm moving on.
Oh, I gotta get that answer down.
I'm gonna need to make a new formula sheet because I'm not happy with this one.
Why is it falling apart?
No, it's not. It's not. Try being married to me. Whew.
Yeah, I'm good. Talk about a nightmare.
Oh, Mr. Adams, let's see how it goes when you're both retired here. Well, I'll call and check in next year.
No doubt. Mr. Adams is gonna be golfing, man. He's not fly fish. He's got a great.
We used to learn how to golf first.
Isn't that right? That's right, bro.
All right. So the volume of a cylinder, there is a formula for that. It's literally the volume is area of the base times height. And guess what the area of the base is? Pi r squared. Because what's the base of a cylinder? A circle. I'm telling you, volume is easier than surface area. Well, I don't need numbers right now. Okay. So the base is truly the area of a circle. Okay. Now, this is what I was talking about. Your formula sheet doesn't have it. So can you jump to your formula sheet? All right. You don't need the parentheses here. I'm just really trying to show you that it's the area of the base, which is a circle, times the height. Now, jump to your formula sheet. Draw your best cylinder. And the volume equals pi r squared times h. So pi r squared, here's your radius, and your height is how tall the cylinder is. Now this is considered a right cylinder, as in it's straight up and down, like my cup here. All right? It's called right, and we just assume if they don't tell you it's a right pyramid, it's a right rectangular prism, because it's straight up and down, it's not slanted. All right, you got it? Volume equals pi r squared h?
Yeah, I got it.
Okay. Now,
vertically write it down in parentheses?
no. You don't, the parentheses are here, so it's fine. The parentheses are just here to sort of show you guys, here's the circle, and then here's the height. But the parentheses, as long as it's all multiplication, you're good. Okay, now, since pi is part of the formula for the volume of a cylinder, you ought to see the volume expressed in terms of pi. That means that this is an exact answer. That this is an exact answer. So we've been doing these exact answers.
So we're going back with the pi.
We're going to come back to pi and rounding. Yep. So find the volume of each figure, express your answer in terms of pi and to the nearest tenth. Okay, we got this. First of all, I need the radius. The volume is pi r squared h. Got it. Yep. All right, so this is the height of the figure. I need the radius. What did they give me? Diameter. So what's your radius? 5, half that. I recommend writing it down, and it's really easy when you fill in the formula just to come back, even though you know better. So, no, someone was staring at me.
Yeah, I'm sure it's
Pi times the radius, which is 5 squared, times the height, which is 12. Okay, now, if we're keeping pi, just leave pi out of it. Type in 5 squared times 12 in your calculator. What is the exact answer? Now I'm going to go with 300 pi. Very close. 25 times 12, that's what we did. 5 squared times 12 is 300 pi, and we would label it what? Feet cubed. All right, type in 300 pi in the calculator, use your pi key, and give me the nearest tenth. So this is your exact, and this is your approximate.
This one's 700.
No, because it's 300 times 3 something. It'd be 900 something.
942 point, what did you say, 10?
Nearest tenth.
5.
Yep. Feet cubed. Yeah, Jordan.
Sure. I'm going to start next one.
Now, this one's not sitting on the base, right? But the base is a circle. So if it would help you, flip it to the side. Volume equals pi r squared h. And even though you might start to sort of memorize these formulas, I think it's good to reference your sheet. So leave your pi there. What's the radius of this one? 12 squared. And what's the height of this one? 11. Okay, so the exact type in your calculator 12 squared times 11. Big number. See if you agree with me. I have 1,584, but what needs to go with it? Pi. And then what we would label it? Miles. Ooh, you're so right. There it was. I made my mistake. Done. Out of my system. Okay, what is the approximate? Don't I wish? What's the approximate?
Of course, the cheese wheel messes you up.
What's the cheese wheel?
Look at it. It looks like a wheel of cheese.
Oh, doesn't it bother you? Because sometimes it looks like it's squeezed in. Does anyone else see that? Oh,
Nah, I see a wheel of cheese.
and now you're hungry.
You like Mr. Untitled Chapter?
Depends on what I'm eating it with.
Oblique.
Extra sharp cheddar. That's what we're sort of hooked on in my house right now. It's got to be extra sharp though.
So wheel, extra sharp.
Yep.
Messes you up.
All right. Oh, here's number 7.
Hey, go back.
All right, look at number 7.
All right, you're on this.
Oh, thank you.
Thank you.
So I need volume, which is pi r squared h, and I have an issue. I've got pi, I've got 4 squared. What am I missing? The height. What did they give me?
You got a slant height.
I do have a slant or a diagonal. Can you envision going across here with the right triangle? Can you see that?
No, I can't see that. I'm blind.
Really?
Tell her Miss Carney not that.
I wouldn't compliment yourself that much.
I'm telling her 2.0.
No, that means the improvers, and I don't know about that. So I have this right triangle. It's like a cross section. And I have the hypotenuse, which is 17. I need to find the height. What's this? Going across the bottom of the circle. Hint, hint, hint. Well, it'd be a leg. It's the diameter of the circle. So what would it be? 8. Fabulous. Okay, so if I need to find the height, it'd be 8 squared plus h squared equals 17 squared. Remember, the hypotenuse is what it equals, and we make that mistake. Okay, so we got to find this. So that's 64 plus h squared equals 289. Now what? Subtract 64, okay.
That gives you 225.
It does, look at you.
And then you got to square root it, and that gives you 15. That's something that's looking.
I'm so glad I didn't fall out of my seat.
Is it actually 15?
It is.
That's not.
It's like Rain Man in here, Mr. Adams.
Well, I just really want to hit these notes. I don't want to do that.
All right, so guys, we're going to get our exact answer by typing in 4 squared times 15, which is?
No, I can't do that.
Oh, come on. 240. I messed up. I want to rewrite that. I'd write it as 2. No, I want to write it as 240 pi. I wrote the pi first. And this would be labeled what? Inches cubed. Oh, there it is again. Inches cubed. Glad you guys are here. What's the approximate volume? I think it just rounds to 754 inches cubed. All right, last part. This, my friends, is what we called an oblique cylinder. Notice that it's sort of pushed to the side like that Leaning Tower of Pisa. We still use the same formula. It's volume equals pi r squared h, but the h has to be the altitude. Altitude, not the slant height. I don't care about the height of this. I need the altitude, but you might use that sometimes. Okay, so find the volume each figure, pi and nearest tenth. So looking at this, they tell you the radius is 8. That's a little bit hard to see. And it says h is 9, and I don't like the placement. But see how they have this? They're giving you the altitude. I don't like how they have it written because it almost looks like they're trying to give you the slant height. They are giving you the real height here. So that's all I need, guys. Volume is pi times the radius squared times the height of 9. So that's not the slant height, that's the actual height. All right, plug that in the calculators.
I still can't believe I did that.
I almost fell out of my chair. I did it again. It's pi times 576. How do we write it? 576 pi. And then I'm going to go with units cubed because they didn't tell me. All right, what is the approximate nearest tenth?
1,600.
Nope.
1,800.
1,800.
9.6 units cubed.
Try and go and give it a 10.
Sorry.
Oh, good.
I mean, you're somewhat close. Okay, look at number 8. This is 5 right in here, and then the height is 15. Okay, this is supposed to be like a dashed line, and the idea is they're showing you the height on the outside, just like they do in an obtuse triangle. So volume equals pi times 5 squared times 15. All right, throw that in the calculator. What is the exact volume? See if we agree.
3,755.
Yep, and what will we label this one? It does say centimeters, so centimeters cubed. What is the approximate? Type in 375 pi. 1,178.1 centimeters cubed. Okay, last one. Super hard to read. So I'm going to write down the information they give you.
Oh, I think you should just write down the answer since it's so very difficult to read.
Well, you're so very difficult to deal with some days, and we still allow it.
Hey, come on, I got that one question.
All right. Not the area. There's my third one. All right. What did they give me? They gave me the volume is 192 pi. And they gave me the height. The height is 2. Now, that's what they gave me. It's hard to read in the figure. They want the diameter. Okay? So remember, they want the diameter. The volume formula is pi r squared h. Do you agree with that? So we know the volume is 192 pi, and that's going to equal pi times what we don't know, r squared, times a height of 2. Now, first thing, do you see that there's pi on both sides? So the pi's divide out. Then I'm going to divide both sides by 2. So take 192 divided by 2. Oh, I think it's supposed to be 12. I just looked at that. Do you see the little 1 there?
Come on, Miss Carmen.
Yeah, it's a 12, guys. It's really hard to see. Now, mathematically, we did the right thing if the height was 2, but the height is 12. So I changed these to 12. So divide by 12, what do you get? 16. And that's much nicer. So how do I get r? Square root. So what does r equal? 4 what? Centimeters. But that's not what they wanted. What did they want? Yep. So what's the diameter? 8. Guaranteed this was like a standardized test, like an SAT. If it was a Keystone, the multiple choice option 4 would have been there, right? That's called a distractor answer, and you wanted the 8.
Where's the line